Think about the very last time you woke up from an incredibly intense, super vivid dream. You're lying there, trying desperately to hold on to it, maybe even reaching for your phone to write it down. But, within seconds, the whole thing just slips through your fingers and vanishes. Well, what if instead of forgetting it, you could just plug in a USB drive and watch it back? Welcome to This Explainer. Today, we're diving headfirst into the rapidly advancing, absolutely mind-blowing science of dream recording technology. We're going to explore how 2026 technology is taking the ultimate sci-fi fantasy and turning it into hard scientific reality, right at the bleeding edge of neuroscience and AI. So, can we actually hit record on a dream? It's a question that has literally baffled humanity for centuries. Since the time of the ancient Egyptians and Greeks, who actually built massive temples specifically to induce healing visions, we've always viewed dreams as these mysterious windows into something way beyond our ordinary waking life. But here is the truly awe-inspiring part. The question of whether we can capture those dreams, it's no longer reserved for mystics or philosophers. Today, it's sitting right on the desks of software engineers and neuroscientists as a completely rigorous, solvable engineering challenge. For a really long time, the absolute best tool we had to record a dream was just a notepad and a therapist's couch. Back in 1899, Sigmund Freud famously called dreams the royal road to the unconscious, basically treating them like a giant psychoanalytic puzzle of repressed wishes and hidden meanings. But to hit record on a dream today, we kind of have to leave Freud's metaphors behind. We aren't decoding dreams with talk therapy anymore. We're decoding them with hard biological data and just massive amounts of computational power. We literally have to map the physical architecture of the brain itself. To build this camera, we first have to figure out exactly when the brain starts filming. Now, we experience two main types of sleep. While you do technically dream in non-rapid eye movement, or NREM sleep, those dreams tend to be kind of dull, thought-like, and really fragmented. But REM sleep, that is where the magic happens. During REM, your body is completely relaxed. Actually, you're literally paralyzed by your brainstem, so you don't physically act out your dreams. Yet while your body is totally frozen, your visual cortex is firing on all cylinders, generating those high-budget, incredibly vivid cinematic experiences we all know so well. It actually helps to think of your brain during REM sleep as a massive movie studio. Your visual cortex, that's the special effects team, rendering all that wild, immersive imagery. The amygdala acts as the emotional director, giving you those intense, visceral feelings of fear or absolute joy. But you might be wondering, why do we accept the most bizarre dream plots as totally normal while they're happening? Well, that's because of our prefrontal cortex. That's the logic-checking producer of this movie studio. And during REM sleep, the producer is completely out to lunch. Your critical thinking is entirely suspended, which is exactly why suddenly finding yourself back in high school taking a math test completely underwater makes perfect sense in the moment. So recording that internal movie isn't about digging around for some hidden MP4 file in your head. It actually requires this incredibly rigorous 4-step translation pipeline. First, we have to detect when the subject is actually dreaming, usually by using an EEG to measure electrical brainwaves. Second, we acquire the neural data. This usually means the subject has to try and sleep inside a huge, noisy fMRI scanner so we can see exactly where the blood is flowing. Third, we use AI to extract and decode those specific features. And finally, step 4, all that decoded data is reconstructed into an actual video narrative. To really grasp how insanely difficult this is, you have to realize that the fMRI isn't actually seeing your dream. It's just measuring blood oxygen levels, watching blood move around different regions of your brain as an indirect proxy for neural activity. It creates this monumentally complex dataset that basically acts as the foreign language of the mind. The true miracle here is when artificial intelligence steps in as the ultimate real-time translation app. Instead of translating, say, French to English, this machine learning model has to figure out visual pixels by translating billions of firing neurons and shifting blood flows. And look, this translation tech wasn't just built overnight. It took a solid decade of rapid, staggering leaps to get here. Back in 2013, the Kamitani lab in Kyoto proved this was biologically possible, but they could only identify really basic blurry categories, like maybe guessing if you were dreaming of a person or a piece of furniture. Fast forward to 2023, and frameworks like Mind Video were actually reconstructing dynamic movie clips. And then we hit a massive breakthrough in 2025 with Dream Connect, a system that doesn't just decode the signal, but can literally manipulate the brain signals using natural language. A huge chunk of this recent acceleration comes straight from the Fudan University team's NeuroPictor framework. See, here's the problem. Everyone's brain architecture is slightly different.
A voxel, which is essentially a 3D pixel representing a tiny cube of brain tissue, lights up totally differently in my brain when I picture a face compared to your brain. For years, reading my mind didn't help a computer read yours. The AI had to be trained for hours on one single person. But NeuroPictor changed the game. It uses a massive data set of fMRI measurements from multiple people, allowing the AI to learn those individual quirks and finally generalize across totally different brains. Okay, but how exactly do we make the jump from static, blurry brain images to fluid, watchable video? Well, they had to come up with a brilliant technological workaround, because an fMRI signal is actually incredibly sluggish. It lags behind your real neural activity by about 4 to 6 seconds, kind of like a desperately slow internet connection trying to load a high-res image. To fix this, the AI uses that slow data to generate semantic keyframes. Think of them as static comic book panels highlighting the major plot points of your dream. Then, video diffusion models and large language models step in as the animators, intelligently filling in the motion and the narrative between those panels so the whole thing plays back super smoothly. All right, prepare yourselves, because this is where the technology goes full inception. The 2025 Dream Connect framework doesn't just sit back and passively watch your dream. Using a dual stream system, it can actively edit the reconstructed dream representation using simple text prompts. Just imagine being hooked up to this, and a researcher types, "turn a horse into a unicorn." The AI actively influences and reshapes the visual output of the dream state in real time. We've officially crossed the line from simply decoding dreams to actively manipulating them. Absolutely wild. Beyond the sheer sci-fi coolness of this, the real-world applications are just absolutely profound. Imagine a therapist being able to safely intervene in a patient's recurring PTSD nightmare, softening the terrifying content in real time while the patient is fast asleep. Or doctors pulling objective biomarkers for depression and Parkinson's disease just by analyzing unique dream patterns. And on a lighter note, think about the creative arts. Filmmakers, painters, writers, they could directly harvest their subconscious imagery. They could literally work in their sleep, turning their nightly rest into an automated creative canvas. But testing all this requires absolutely perfect data. And relying on people trying to remember their messy dreams after they wake up, that is notoriously unreliable. So scientists are relying heavily on lucid dreamers. These are folks who actually know they're dreaming while they're asleep. By tracking their heightened alpha waves, which biologically proves they're in a conscious dream state, researchers can watch for pre-agreed physical eye movements. The dreamer can literally look left, right in their dream to signal the waking world, "Hey, I'm looking at a car right now." It gives the AI perfectly time-stamped data to decode. Now, it's honestly impossible to talk about this level of access without stopping to discuss the massive ethical implications. Dreams are quite literally our most intimate possible content, right? It's a state where social performance, all our secrets, and rational censorship are entirely suspended. A technology capable of reading this content without a person's knowledge, or even manipulating it, represents an unprecedented frontier. We really have to ask, what happens when the ultimate private space becomes searchable, accessible data? And this brings us to what might just be the most crucial civil liberties fight of the next decade: neural rights. International law is currently in an absolute dead sprint trying to catch up to this tech, framing mental privacy as our primary defense against potential coercive brain surveillance. Chile actually recognized this super early on, amending its constitution way back in 2021 to protect brain data. By 2025, UNESCO adopted a global ethical framework, and we are now seeing targeted mental privacy laws sweeping across various US states. So there is a rapidly growing bipartisan and international consensus forming here. The raw data generated by your brain requires legal protections that go far, far beyond what our current digital privacy laws cover. Okay, so let's project this forward. When does this actually arrive in your bedroom? Right now, as we talked about, recording a dream requires a massive, multi-million-dollar hospital fMRI machine. But thanks to something called EEG to fMRI transfer learning, that timeline is shrinking fast. AI is currently learning how to guess what the giant hospital machine would see, just by looking at data from a cheap, comfortable, wearable EEG headband. So within 5 to 10 years, you could theoretically record rough cuts of your dreams at home. Within 10 to 25 years, we're looking at high-fidelity playback. And beyond that, we might literally enter an era of full interpersonal dream sharing.
So as we wrap up this explainer, I want to leave you with a really profound thought about the hard problem of consciousness and what humanity gains and potentially loses when we finally hit record on the mind. The dreaming mind truly is our last uncompromised private space. Are we genuinely ready to hand over the keys? Recording our dreams is absolutely going to give us miraculous insight into who we are and how our minds work. But whether we use this technology to heal, to create, or to surveil, well, that's entirely up to us. Thank you so much for diving into this with me.